What is up, Flutter devs? Damn, it feels good to say that again. It's been a while since I last posted a Flutter live coding video. I went and spent a couple years on the Flutter team, but now I'm back. This video is the first in a brand new series that I'm calling Widget Workshops. Widget Workshops are relatively brief live coding exercises where I show you how to create some specific widget or some specific visual effect in Flutter. These workshops will typically range from 20 minutes to an hour, depending on what we're building. Now, in today's workshop, we're going to pay homage to my time working at Nest. We're going to create a little text scrolling widget that fades in at the top and fades out at the bottom. It's inspired by a similar visual element on the home screen of the Nest app that displays your address and the local weather flipping between the two. We'll get into that workshop in just a moment, but before we do, I'd like to ask a favor. I left the Flutter team so that I could help show the world the power that Flutter offers as a UI toolkit and to help the world adopt Flutter. I truly believe a world full of Flutter UIs is a better world for all of us, but getting that message out requires an audience, and I need your help building it up. I'm starting this YouTube thing all over again, and I've got to build up from nothing with this channel. So if you would, spread the word. Like the videos if you enjoy them, subscribe to the channel, share this video with your own friends, colleagues, and your own audience. In fact, let's see how quickly we can get this channel to 10,000 subscribers. I mean, there are few groups as great as the Flutter community, so I bet we can hit that number in no time. What do you say? Will you help? Now, enough about me. Let's get into the workshop. Welcome to today's Widget Workshop. As you can see with the simulator on the screen, I'm paying homage to my history working on the Nest app. We have a UI here that's a rough facsimile of what you would see in the Nest app. And we have this black box here that's waiting for us to fill it in. Now, those of you who have never used the Nest app, you may have no idea what goes in that box. But what we're looking to create here is a message that scrolls. Like message 1 scrolls down, message 2 comes in, message 2 scrolls down, message 1 comes back in, and it just keeps flipping around and around. So that's our goal for today. The challenge here, at first you might think it's very easy. Use a column, 2 items in the column, animate the column up and down, and maybe mask it or something. The challenge here is that we want the bottom and the top of this message scrolling system to fade to the background. We want the text to fade at the top and fade at the bottom. And I actually don't know how to accomplish that with widgets. So if any of you know, please add it down in the comments. But the challenge is then, how do we get that fade at the top and the bottom? And for me, the answer is use a custom painter. So that's going to be our primary approach here, and that's what makes it a little more complicated than just throwing a few widgets together. So with that said, our goal here is to create that rotating text scroller with a fade at the top and the bottom using a custom paint. So let's jump in and make it happen. The first step for us is to introduce a custom paint and a custom painter in place of this container that's drawing the black box. So let's go ahead and throw that in there. Instead of the container, we want a custom paint. Just to make sure that it takes up all available space, we can give the custom paint a size, which we will make infinite, which means take up all available space. And then we're going to want a painter, which we will call text scroll painter. We will implement the 2 necessary methods within text scroll painter. We don't care about optimizations for now, so we will always repaint. And now we need to ask ourselves, what fundamental properties do we need to be able to paint this text that we're concerned about, these messages that we want to show? We will need label 1 and we will need label 2. If you want to extend this creation, you could have X number of labels and you can take that in as an array or something, but we're going to hard code this to 2 labels for now to make it easier on ourselves. And we're also going to want some kind of scroll position. So let's take all of these into a constructor. And we'll make the labels required, and we'll give a default position of 0 to the scroll position. Now back up here where we actually use the text scroll painter, label 1 will be Flutter Education, and label 2 will be Flutter Training, both of which, of course, are services that I provide. Scroll position, we will begin with 0 for now until we get to a point where we can actually make use of that. Let's see, what are we complaining about? It's complaining about the infinite size, so let's see what happens without that, see if we're okay. No, I think it needed that. Oh, I tell you what, we want to be as wide as possible, but we don't want to be as tall as possible. So we want a size which is infinitely wide, but we actually only want to be 30 pixels tall. And now we're fine. So obviously we're not painting anything yet. We need to actually implement this paint method, but we're now configured to paint something. And what is it that we're going to paint? Well, we need to paint text. We need to paint 2 labels, one above the other. And when you paint text, it's a little more involved than just using a text widget. You actually need a paragraph builder. And then from the paragraph builder, you build a paragraph, and then you lay out and paint the paragraph. Let's do that for one label, and then we'll extract a function so we can easily do it for the second label. First, we need a paragraph builder. A paragraph builder takes a paragraph style. And what we want to specify in this paragraph style is that we are aligning our text to the center. And in our case, we only want 1 line of content. And we're also going to add text to this builder. In this case, we'll add label 1. And then we want a paragraph, which is based on the paragraph builder. And we can also, after we build, we can also immediately call layout. Because again, we don't live in the widget world here. We can paint any dimensions we want. So part of that process is providing these paragraph constraints. And all we care about giving is a width. Our max width is whatever our drawable, essentially the width of the screen is. That's the most width we want to give to this paragraph. And at that point, we have a paragraph and we can actually paint it. So we can draw a paragraph, we'll pass in the paragraph. For the offset, we'll go with 0 for now and see what we get. Okay, and there we see Flutter Education painted on the screen at the center of our drawable area. The Y position is not correct yet. In fact, let's just correct that right now. So offset, instead of 0, we'll make the X 0. But for the Y offset, let's get the height of this paragraph. And then let's take the available height. So we'll take size.height minus line height divided by 2. And you'll notice now that our text moved down a little bit. And that's because we just vertically centered the text in our available space. We've now created a paragraph builder with a given label. We produced a paragraph from it. We laid it out at the appropriate constraints. And based on the line height, we drew it at the center of the screen or center of available space and vertically centered. But that's just one paragraph. We need to do this for label 1 and label 2. Now, there's no need to repeat most of this, so let's extract this into a local method that we can just invoke for both of our labels. With build paragraph defined, we can come back up here and say paragraph 1 equals build paragraph. We'll send in label 1, and we'll send in the available size. Then we have line height, and again, we can draw paragraph 1. Because this text scrolls, what we want to do is position label 2 above label 1, and then we push them both down, and then we move label 1 above label 2 and do it again. That means that the position of label 2 is based on label 1, which means that this calculation that we do right here for the Y position, we want to yank that out. In fact, we'll yank out the entire offset. We can then use that offset for the second paragraph. Final paragraph, paragraph 2 equals build paragraph, label 2, pass in the available space, which is size. We don't care about the line height, or we're going to assume the same line height for both of these because it's unclear what the design should be if the line height isn't the same. And so now we need an offset for label 2, and we're going to say label 1 position, translate, no difference on the X. We want to do something with the Y. We're going to subtract the height of our available space. So each label is vertically centered within the entire size, the entire height available to our painter. So this is the available space for label 1, and label 1's right there, centered in it. And then label 2 is up here, centered right there. Let's see. Okay, so in the build paragraph, I need to use the incoming label, not label 1. So that was a mistake. And now if we look at the simulator, even though it's hard to see what's going on here, above Flutter Education is Flutter Training, and that's the second label, and that's the label that needs to come down to replace the first label. In the next step, we're going to go ahead and introduce some animations so we get these labels pushing down. And then after the animation is doing what it should, we'll look at actually cropping out and fading this text to get the desired effect. Let's integrate an animation controller so we can get these labels moving up and down the way they're supposed to. Up here in our stateful widget, since we're going to animate, we need to bring in a single ticker provider state mixin, and then we're going to declare an animation controller. We will initialize the animation controller in init state. We'll pass ourselves as the vsync, and the duration will be 2 seconds. We'll add a listener, which is invoked every time the animation changes, and we'll call set state to redraw ourselves. We will also add a status listener. And if the status is animation status completed, we're going to restart the animation so that it's always running. And after we initialize the animation controller, we're going to immediately start it running. So it's going to start running immediately, and it's always going to keep running. Of course, we need to dispose of the animation controller in the dispose method. Now, this animation controller is going to produce a value that we're going to send in for the scroll position. But that's not going to do anything for us yet because we haven't implemented any math within our painter that actually accounts for the scroll position. Let's go look down in our painter. And right here where we calculate label 1 position, that essentially shouldn't be static. This is fine. This Y value is fine for the initial position, but we want to add something to it. We want to take the available height and we want to multiply it by the scroll position. So when scroll position is 0, our label is just sitting at its original position. But every little incremental amount that scroll position changes, and by the way, that's a percentage value between 0 and 1, we want to move an entire height's worth down, which brings label 2 into the center of the available space. Let's see what we get with this behavior. We need to do a hot restart because we need to initialize the animation controller. And there we go. So we're moving up and down, or we're moving down as we expect. So every 2 seconds, we move down the desired amount. But of course, there are multiple visual issues here. The first issue that we're going to solve is the fact that the moment that Flutter training gets down to its final position, it's correct to reset the position of the labels, but we need to switch the labels. Every time the animation reaches the end, label 1 needs to become label 2 and label 2 needs to become label 1. What that means is that these hard-coded values right here can't be hard-coded. Instead, we need to come up here in our state object. We need to have a string, which is label 1, which will initially be Flutter Education. And string label 2 will be Flutter Training. And then we will define a local method called switch labels. And we will say if label 1 is equal to Flutter Education, then label 1 needs to become Flutter Training, and label 2 needs to become Flutter Education. Otherwise, we do the opposite. Of course, one, it's not good practice to type this out because there might be a typo. They should be in constants at least. And 2, if you're dealing with more than 2 labels, you need to do this kind of thing in some other fashion, looping or reference them based on index or something else. But this is just because of how simple these 2 labels are and the fact that we're not really worried about being robust from a production standpoint. Anyways, switch labels will flip the 2, and we want to execute that every time the animation completes. We want to switch labels. And then when we actually paint this thing, label 1 should be label 1, and label 2 should be label 2. And let's see what this does for us. Let's do a hot restart. Now notice that visually it appears like whatever label is on the bottom jumps to the top. And so now we can kind of see that staircasing effect where it looks like one message goes from top to bottom and the next message goes from top to bottom. Obviously, we shouldn't be painting both of them at the same time, but one problem at a time. Now, a second issue that we want to address is that we don't actually want these messages always moving at a constant rate from top to bottom. We actually want them to pause for a moment and then continue switching again. To accomplish this, we are going to use a curve, an animation curve, but it's just called curve. And we'll call it an animation curve. And specifically, we're going to use one that's called an interval. An interval defines periods at the beginning and the end where nothing happens. Okay? So so for the first 30%, we'll do nothing, then 70%. And the overall motion curve that's going to apply in between is going to be an eased in-out curve. That means instead of linear constant motion, we speed up and then we slow down. Speed up, slow down. So interval, again, gives us some dead time. Let's jump in here and look at this definition. A curve that is at 0% until the beginning value, then curved, and then 1% by the end, and it stays at 1%. So it's going back to our definition, we're at 0 until we hit 30%, then we start animating. And then when we hit 70%, we're at 1 or 100% of the motion, and we stop moving. And then in between 30% and 70%, we speed up and slow down. And we're going to apply this curve directly. We could set up some kind of tween. I think it's unnecessary. We can just come down here and take the animation controller value, and we can tell our animation curve to transform that value. Let's save, and I'm going to do a hot... Okay, I went ahead and applied. So you can see now that our motion has changed. Two things have happened. You can clearly see that we're speeding up and slowing down, and you can also see that there's a period of time where the text doesn't move. So we have time to read it, then it transitions, and then we can read it. And of course, if you wanted, you can make the duration longer, you can make it shorter, you can have the text stay still longer or not. It's totally up to you. But this interval and using this transform is how we accomplish that motion. In the next step, we're going to look at the basis for how we're going to achieve this fade out. So again, even in the widget layer, you could clip the desired area, but we don't just want to clip. We don't just want to hide the text that shouldn't be visible. We want it to fade. And so in the next section, we're going to look conceptually at how we achieve that. To get us started with this next step, I'm going to begin by painting something additional onto the screen to show you how I'm thinking about the problem. We're going to paint a gradient so you see what it means to fade, but then we're going to use that gradient in a different way after that to actually achieve the fade. So again, the first thing we're going to do is draw the gradient, which isn't what we want to do in the end, but it's what we're going to begin with. We're going to declare a linear gradient here, and we're going to initialize it in our initializer list. A linear gradient is a series of colors. The colors don't really matter in this case, so we'll just go with white. But the important part is that we're going to start with no opacity. We're going to start completely transparent, and then we're going to go to completely opaque, and we're going to stay opaque for a while, and then we're going to go to completely transparent again. We're also going to establish where this begins and ends. We're going from the top to the bottom. And then we're going to give specific stops. We don't want our colors to be evenly spaced. We want our particular colors to hit their primary point at different locations or at non-standard locations. So we want the first stop to be just 5% from the top. Then we want the second stop to be 30%. then 70%, and finally 95%. What this does, what this has the effect of doing, is it takes the transparent parts and it really pushes them to the fringe. So we have just a little bit of transparency at the top and the bottom. Now, with this gradient in hand, I'm going to come down here into our paint method, and we need to produce a paint object to paint with. We'll call it, I guess, fade paint. Okay, I forgot. So the fade, okay, so what we need to start with is a shader. The linear gradient, which we called fade gradient, it can create a shader. Now a shader needs to apply to a specific rectangle, and we're going to base that rectangle on our size. From 0, 0 to size.width, size.height. So this shader applies to all of our available space. And then we can create a fade paint. We create a paint, and we set the shader to the fade shader. And then finally, we tell the canvas that we just want to essentially fill all available space with this paint. Now let's see what we've got. All right, so now you see this white gradient looking thing. The reason I've drawn this here is because the part at the top and the bottom of this gradient where it becomes white and then at the bottom it fades out from white, we would like our text to be drawn in such a manner that it essentially intersects this gradient. If our text intersects this gradient, then our text won't be visible above or below this gradient. And when the text initially comes in, notice that the gradient is faded, so our text will be faded. And when the text goes out the bottom, once again, the gradient is faded, so our text will be faded. If we can somehow superimpose or intersect our text with this gradient, that would seem to solve our problems. And that's what we're going to do in the next step. In this step, we're going to use the concept of a linear gradient and a shader to actually paint our text with that gradient and achieve a blending effect. To do this, we need, well, first we need to make a kind of syntax change. Paragraph Builder and Paragraph and all these other things, they come from the Dart UI package. There's a naming conflict in that package that we're about to run into, which is text style is defined both in the widget space and in the Dart UI package, and they're actually different things. We now need the text style from the Dart UI package. So I'm going to come up to the top here where we import Dart UI, and I'm going to refer to it as UI. So everything from that package now requires UI to prefix it, and that will get rid of our conflict. But I first need to come down here and add UI dot before a number of these artifacts. In front of paragraph, paragraph builder, paragraph style, paragraph constraints. All right, I think we're now back to normal, and so now we can use UI.textStyle without a conflict. In here in build paragraph, we have an opportunity to apply a desired paint. Let's take a paint in here. Here's the interesting part where we kind of accomplish the magic of this workshop. When we create the paragraph builder, we can push a style. And this again is a UI text style. It's not the normal one that you're used to working with. It allows us to define a foreground paint. And we can just provide our paint. And of course, the cool thing about paint is that it doesn't just have to be a color. It can have, again, gradients, blend modes, all sorts of interesting things. And we can apply that. We can essentially intersect it with our text. That's what we're doing here. With this change to build paragraph, let's come back up to our paint method. And remember that we had this shader and in paint here. we don't want to paint the gradient anymore, because obviously what you see here on the screen is not what we want, but we do still want the shader and the paint. So let's move that up to the top of our method here, and we have this fade paint. Let's pass the fade paint to both of our build paragraph methods. And now let's save that and see what happens. Do you guys see what's going on? Let me slow it way down for you to make sure that you see what's happening. Do you see that fade? There's a fade at the bottom and there's a fade at the top, because the path that represents our text is now essentially being intersected with that white gradient that we were previously painting on the screen. And that's what gives us the fade. And this, by the way, this is why I approached this with a custom painter and not a widget tree. If you know how to do this with a widget tree, by all means, write it in the comments down below, and I'd be happy to take a look. But the only answer that I knew was to use the custom painter. So this is definitely the coolest part of what we're trying to accomplish here, but we do still need a tiny bit of cleanup, and we're going to do that in our final step. For this final step, I want to introduce just a couple of parameters that give us a little more control over our message display. I would like for our text scroll painter to support a font size, and we'll default to, let's say, 14. I would also like to receive a text color. And actually, so the color we can bring in as just a property, but the font size we will save locally. So down here, we will introduce a font size. As for the text color, the reason that we don't need to hold on to that is because we're going to take that text color and we're going to apply it immediately to our linear gradient. Because maybe we don't want this text to always be white, right? So we want to be able to configure that gradient. And again, we want to be able to modify the font size. And then, so the color is already applied for us. Now down here in build paragraph, let's see, I always forget which of these areas actually takes the font size. Okay, so it looks like push style will allow us to reference the font size. And with that, we should have greater control over our text scroll painter. So let's give it the text color. And just to prove that this works, let's go with, I don't know, green. And then for the font size, let's make it pretty big. Go with 22. And you can see over here, large green font. Let me hot restart to get the faster animation time back. All right, green, and we could go yellow, which is clearly my favorite color. But now what we actually want here for this particular design is we want to drop back down to 16 for the font size. And we want to go, we still want white, but we actually want an opacity, let's say 60% opaque. And that's really what we want for this design. Now we have control of the two labels that we pass in. We can choose any font size we want. We can use any font color with any maximum opacity. And we have our text animating. It sits for a little bit, then it animates, then it sits, then it animates, and it fades at the top and it fades at the bottom. So this is our text scroller completed. And that's the end of this widget workshop. I'll see you in the next one.